Hi, I'm Nun Hui, and today our group would like to talk about logic gates. So here's our group members: Chia, Jocelyn, Kuijing, Yichen, Xia, and Wen Hui. So Chia will be our group leader. So for the content, we will be discussing about the introduction, history, inventor, table, diagram, usage, formula, effect, and conclusion. So first, let's start off with the introduction. Logic gates are the basic building blocks of any digital system. Undeniably, they play a large role in our daily lives. As modernization continues, there are an essential wide range of electronic devices that we use daily. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and the output is based on a certain logic. Logic gate consists of AND, OR, NOT, NAND, NOR, XOR, XNOR gates. One of the most common applications of logic gates is in computers. Computers use logic gates to perform arithmetic operations, logical operations, and memory operations. Smartphones also use logic gates to process information from device sensors, such as the accelerometer, to detect movement. Logic gates are also used in industrial and scientific applications. For example, logic gates are used in control systems for factories and manufacturing plants. These gates are also used to process signals from sensors and to control the operation of machinery and equipment. Logic gates are also used in scientific instruments such as oscilloscope and spectrum analyzers to process and display signals from sensors and other sources. Therefore, logic gates are an essential part of modern electronics and our daily lives. They allow us to process and manipulate digital signals quickly and efficiently, enabling us to perform complex tasks with ease. As technology continues to evolve, logic gates will remain a fundamental building block of modern electronics, and their importance in our daily lives will only continue to grow.
Now I'll explain about the history of logic gate. The history of logic gate can be traced back to the mid-19th century, where mathematicians and philosophers began to explore the concept of formal logic. The development of Boolean algebra by George Boole in the 1850s was a significant breakthrough in this field, and it laid the groundwork for the design of digital circuits based on binary logic. The first practical application of logic gates was in the development of telegraph networks in the late 19th century. The American engineer and inventor Claude Shannon is credited with laying the foundation of digital circuit design in his 1938 paper, A Symbolic Analysis of Relay and Switching Circuits. In this paper, he showed how Boolean algebra could be used to design circuits that could perform mathematical operations. In the 1930s, vacuum tube technology was developed, which allowed for the construction of faster and more complex circuits. Then the invention of the transistor in 1947 by William Shockley, Walter Brattain, and John Bardeen revolutionized the electronics industry and paved the way for the development of modern logic gates. The first integrated circuits, which contained multiple transistors on a single chip, were then developed in the 1960s. Today, logic gates are an essential component of modern digital electronics and are used in a wide range of devices. So, who is the inventor of logic gate? The concept of the logic gate was developed by a number of mathematicians and engineers over time. However, the invention of the modern electronic logic gate is usually attributed to Claude Shannon, an American mathematician and electrical engineer. He introduced the concept of Boolean algebra in his 1938 paper. He also demonstrated that any logical function could be expressed as a combination of the basic logical operations of AND, OR, and NOT. His work laid the foundation for the development of digital circuit design and paved the way for the invention of the transistor and the subsequent development of modern electronic logic gates.
I'm Yichen, and now I will explain about the diagram and truth table of logic gates. First is an AND gate. An AND gate takes two or more input signals and produces a single output signal that is high or ones only when all input signals are high. The Boolean expression for an AND gate with two inputs X and Y is X times Y. Secondly is the OR gate. An OR gate takes two or more input signals and produces a single output signal that is high or 1 when at least one input signal is high. The Boolean expression for an AND gate with two inputs x and y is x plus y. Thirdly is a NOR gate. A NOT gate takes a single input signal and produces an output signal that is the opposite of the input signal. That is, if the input is high or 1, the output is low or 0, and vice versa. The Boolean expression for a NOT gate with input x is negation x. Other than the three basic logic gates, there are advanced logic gates such as the exclusive OR. An exclusive OR gate accepts two input signals and creates an output signal that is high or 1 when the input signals are different, and the low or 0 when they are the same. Next, a NOR gate. A NOR gate combines an OR gate with a NOT gate. It receives two or more input signals and creates a high or 1 output signal only when all input signals are low or 0. A NOR gate with two inputs x and y has the Boolean equations negation x plus y. Last but not least, a NAND gate. A NAND gate combines a NOT gate and an AND gate. It accepts two or more input signals and only generates a low or 0 output signal when all input signals are high or 1. A NAND gate with two inputs x and y has the Boolean equations negation of x times y.
Next, we have the formula for the logic gates. There are 7 main logic gates, which are the AND, OR, NOT, XOR, NAND, NOR, and XOR gate. These 7 logic gates are the most commonly found and applied logic gates. We also have Boolean algebra, which are theorems and formulas which are used to simplify logical statements. This table shows the few common theorems for AND and OR logic gates. Here we have a diagram of the universal logic gates, which are logic gates that can inform all other logic gates using only copies of itself. The most common example of these are the NAND gate and NOR gate, which on the right we have an example for the NAND gate as a universal logic gate.
Hi, I'm Jocelyn. I will now discuss about the usage of logic gates in our daily life. Logic gates are utilized in various circuits. For the first gate, which is AND gate, we use it in the security system. Only when the light sensor detects the darkness and the infrared sensor detects the intruder, then it will trigger the siren. Moving on to the next gate, OR gate. If it is necessary to detect occurrence of one or more events or to take certain action after they happen, OR gates can be used. For example, OR gate is used in the doorbell. One can press either the front doorbell switch or the back doorbell switch for the doorbell to ring. The next gate is NOT gate. NOT gates are also known as inverter because they invert the output given to them and show the reverse result. The advantage of using this gate is it consumes low power and their interfacing is very easy compared to the other logic gates. For example, if the temperature is above 20 degrees Celsius, then the central heating is switched off and vice versa. Next, I will talk about the application of the NAND gate in our daily life. For instance, device failure alarm system. When the fans are working, the input to the NAND gate is 1, 1 and the output is 0. If any of the fans stop working, the output of the NAND gate becomes 1, which activates the alarm. Another example is burglar alarm. When either the window or the door is open, one of the inputs is low, the output is high, and the alarm will produce the buzzer sounds. Lastly, the NOR gate. A washing machine has 3 sensors to check for washing machine lid open, washing tub filled to minimum level, and the weight of clothes. If the machine lid is open, or the water in the tub is below certain level, or the machine is overloaded, producing a 0 at the NOR gate output and switches the machine off.
Moving on, I will be presenting the impact of logic gate to human life. So the first advantage of logic gate is about the low-cost solution. The basic logic gates like AND, OR, NOT, and TTL are less expensive. Thus, the use of logic gate is cost-effective in the design of and use in the electronic industry. The next advantage is simplicity. Due to the simple and easy structure of logic gates, it can be used to design more complex digital circuits using switches and also circuits. The third advantage is compact size. Logic gates are small and compact, thus making them ideal for making small and lightweight electronic devices like smartphones and laptops. The next advantage is low power consumption. Power consumption of logic gates usually ranges in several megawatts. For example, the Scotty TTL logic gates uses less than 2 megawatts per gate, which can help to save more energy. The last advantage is reliable signal rectification. The logic gates can fix the input noise that results in the signal not correctly switching from 0 watt to 5 watt or 1 and 0 respectively. This is the ability that is desired in logic circuits and why they are commonly used throughout the industry. However, there are also some disadvantages about the logic gates. The first disadvantage is about the limited set of operations. The logic gates uses only limited sets of operation like AND gate, OR gate, and NOT gate, which should only accept 2 sets of input, on and off, or 1 or 0. It could only process digital signals but not suited for analog signals, which consist of different ranges of values. The next disadvantage is the delay of propagation. Logic gates take time for input to be converted into output, which causes some propagation delay, especially in larger and more complex circuits. This could lower the efficiency of application that needs higher speed processing. The last disadvantage is about the limited operating voltage. Logic gates are designed to operate within a certain range of voltage, usually between 0 to 5 V for TTL logic gates. If the input voltage exceeds the range, the logic gate may be damaged or malfunction.
In conclusion, logic gates are an essential component of modern electronics, and they play a crucial role in our daily lives, consisting of AND, OR, NOT, NAND, NOR, XOR, XNOR gates. They are used in a wide range of devices, from smartphones and computers to industrial control systems and scientific instruments. By processing and manipulating digital signals, logic gates enable us to perform complex tasks quickly and efficiently, revolutionizing the way we interact with technology. Although it has some cons, logic gates will remain a fundamental building block of modern electronics, and their impact on our daily lives will only continue to grow. So that's all from our group. Thank you for listening.